Okay, hi guys. My name is Mike Kolesnik. I'm part of the cloud networking team here in Red Hat. The last half year I have been working on the oVirt Neutron integration, and I wanted to share with you the work that we did and basically the internals, the details of how it works behind the scenes. So we're going to talk about first of all, a little introduction about oVirt network configuration, and then we'll go over Neutron, see what we want to get from the integration, and see how we integrated the Neutron into oVirt. If we have the time, we'll deep dive into how it's done under the hood, and in the end, we'll talk about future work and open questions that we still have. All right, so oVirt network configuration. If you don't know yet, we'll go over it very briefly. Network in oVirt is a logical entity that represents a layer 2 broadcast domain. What does it mean? That if a VM, let's say, is starting or migrating, then it sends our packet after migration to let the switches know. So basically, that's the major limitation that we have, but that's how we represent the network, and we can put network parameters like a VLAN tag. We can set the MTU. We'll see it in a while. And how we define the network is in the scope of a data center. So for each data center, we can define which networks exist on it. So we can see in this screenshot of oVirt the networks view and the few networks that we have on the data center. Now, when we want to add a new network, we just click Add in the networks view, and we fill the name of the network, and we define the network properties like VLAN, MTU, and if it's going to be used by VMs or not VMs. So how it's done behind the scenes is VM networking is implemented in oVirt via Linux bridge technology. So for each network we create a bridge, and all the VMs connect to that bridge. And VLANs in Linux are used as a virtualization enabler, so that we can provide several virtual networks on the same physical link. Okay, so here you can see that we can set the VLAN tag that you want for that network. You can select any tag that you like from the correct range, and you can set if it's a VM network or not. And behind the scenes, what happens on the host is that you get a VLAN device for VLAN 1500 created, and on top of it, we create a bridge that the VMs connect to. So that's the basic view of the network. That's just the basic details, and that's the logical definition. It's still not sent to any host. And before we can set it on a host, we need to attach it to a cluster to make it available in cluster. So how do we do that? We just go to the cluster tab in the dialog, and we can select which clusters we want the network on. Right? So now that we added the network, we can also set on the cluster level like network role if you want migration or display, but this is still not available in this dialog. It will be available in the future, and we can set it in the cluster view anyway, right? So now that we added the network and it's attached to a cluster, that's like the most basic. We need to configure it on the host. So we go to each host, and there's a button called Setup Networks there. We click Setup Networks, and what we see is this dialog. In the left side, we can see the host physical interfaces. So you can see the host has some bonds defined, and the bonds contain some actually physical NICs. And on the right side, we can attach networks to each of the physical interfaces. So either we attach the networks over the bond, or we can attach a network directly to a physical interface. And we can see even that we can, like I said, virtualize the network and use the same physical interface for several virtual networks, right? And then when we click OK, this command is sent to the host, and the host is running the set of networks command. It's actually configuring the network over the network. So if there's like a network connectivity problem, there's this checkbox here that makes sure that if the command fails and you lost the network connectivity to the host, you don't have to go and manually restore it. You don't have to go and open a console on the host and start like typing in things in your data center. It just rolls back to the last same configuration that it had before you ran the command. So that's a really nice capability of this command. And here we can see the networks are actually statically defined on each host. So we have to go to each host and run a set of networks in order to be able to use them later on. If we don't set the networks on the host, then we can't use them later when running the VM. Like the host will exist and it will be maybe operational. Depends if the network is required or not. And the VM still may not run on the host because it's missing some network. Like it has this non-VM MTU 9000 network that it needs, but we didn't set it on this host, so it won't run on this host. And also, because the networks are statically defined, we can see if the network is available currently or not, if the actual link is working or not. So we can also make a smart decision and not schedule a VM to run on a host that doesn't actually have the network. Maybe it's defined there, maybe it should be able to provide it, but it doesn't currently. The cable is cut or something like that, right? So that's the groundwork for networking. You go, you create networks attached to clusters and set them on the host level, right? And after that, you can actually go and add the network to a virtual NIC. We can see that in the new virtual machine dialog, we can select which network you want to use on the NIC, or we can go later on and add additional NICs and just select which network they use. So these networks are the networks that we attach to the cluster, right? These are the networks that are available for selection. Okay? That was basically oVirt networking in a gist, really quickly. Hopefully everyone understood. And we'll go over Neutron now and see what Neutron has to offer. So what's Neutron? Neutron is a service that provides network connectivity as a service. So we can go to it and ask it, like, hey Neutron, I want a new network. Give me like a new network that I can use. And it's really really powerful in the cloud. Like a tenant can go and create several networks, and these networks are segregated from other tenants. So it's really a good service that we can use. And it also has this plug-in architecture. And in the plug-in architecture, we can support various technologies of networking and various hardware even through the plugins. The plugins, they implement set API, the Neutron API, and maybe they have some extensions to make the usage a bit more advanced. But they have this, all have this basic API that you use to create networks, to create ports, to create layer 3 networks. And the available plugins, there are many, but the most basic ones are Linux Bridge plugin, OpenStack Switch, and there's some Cisco plugin, a Nexus plugin, etc., etc. Right? So let's see, how does it look? We have on the left side API clients that connect to a REST API. So that's just a basic API that says, like, create network, update network, create port, update port, basic operations like that. And there's some API extensions that each plugin can provide. So it maybe provides some extension for security groups, or maybe extension for provider networks, right? But each plugin can provide its own extensions. And actually, on the backend side of the Neutron server, we have the plugin itself. So the plugin itself also, it actually implements these methods of create network, create port, etc. And also the API extensions, it knows how to handle them. So this is basically the Neutron service. It's the API plus the plugin, right? So when you set up Neutron, you have to set up one machine that has this, the API plus plugin. This is the service, this is the logical entity. And on each compute node is where you actually run your VM. So in oVirt, it's where VDSM is installed. It's the host. There you have either an agent, or it's controlled by an external controller, and this is it's related to the plugin type that you use. Like for Linux Bridge and Open vSwitch plugins, we use agents, but for other types of plugins, it's just external controllers. It's one machine or several machines that sit somewhere on the network, and they control the host. They set the rules for networking. Yes.
Can run in a compute node?
You can set the Neutron service everywhere you want. As long as you have access to it, it's fine. So there's even, I think, a redundancy there. You can have several services running on several nodes, like load balancing and high availability, stuff like that. But it's no problem. You can set everything on the same node or different nodes. It's very like modular architecture, right?
The service that accepts the API calls, that can sit on specifically a separate host than the plugin that actually implements the API?
No, this together. This is the service. Not you can't have just the API.
Okay, and let's say that I'm using an SPM controller. Can that sit on a different host than the host that runs the Neutron service?
Yeah, the plugin is not the controller itself. The plugin just implements the methods that the API exposes, and the plugin just talks to the controller and tells him like, hey, this network is created, go and do something about it. Okay. Someone on the line had a question?
Yes. As I understand, some of the compute nodes are running agents. So does the agent have a separate API, or do they access directly the database?
It's an internal API. It's not exposed. You can't like rely on it in order to communicate to Neutron. The way you communicate with Neutron is through the REST API, just from the left side of the slide. You use the REST API, and
so, but your question was, how does the agent communicate with the plugin, or how
does it obtain the information? How does it obtain the information that it needs to actually establish a network?
Okay, first of all, it's implementation specific region, so each plugin can implement it in any way they want. There is the Cupid from the service that used for the communication between the agent and the actual implementation of the plugin. But actually, we have Bob on the line, who is a core maintainer in Neutron, and maybe he can enlighten us if he.
Well, I think maybe we can save this question for later and see if it's answered or not, because we have in the deep dive to how it works on the host, we actually have an explanation of how the internal communication, like what's being done on a high level, so maybe this will answer the question. Okay? So if there are no further questions, I'd like to move on to actually get to the deep dive. Okay. So what do we stand to gain from integrating with Neutron as oVirt? So first of all, we would gain a lot of cool technologies that the various plugins provide. Like In Neutron, as I said, we only work with Linux Bridge. That's the implementation that we use, and VLANs and basic Linux stuff. And if you want to add like OVS, OpenVSwitch support or Cisco support, then we need to integrate with each product directly. So this saves us the hassle of integrating with each product because it's a standard API. It's a standard set API that we can use. So this gives us all the advanced technologies like for free. That's one point. Another point is that we want to leverage the layer 3 services that are provided by Neutron. Like Neutron provides IP address management, it provides load balancing as a service, it provides firewall as a service and routing capabilities. It's always these services are evolving and more services are added. So want to be able to leverage these services to provide, for example, IP address management for the VMs so that the administrator doesn't have to go physically to a DHCP server and configure it. He can just do it through oVirt, which will in turn do it through Neutron. So that's another point. And basically, we want to have to enjoy both worlds. Like we want to have Neutron for managing the VM networks and providing all these advanced services, the layer 3 services, and the advanced connectivity. And oVirt, we will still use it, but for managing the infrastructure network that is statically set, like the migration, storage, display data, etc. So basically Neutron, most of the networking there, all of the networking there is dynamic. You can't know the network is there before you create a VM, and the network connection is created dynamically when you create a VM, but we will see it later on. And of course, we still don't block anyone from using good old-fashioned VM networks, right? We still want to allow people to use the oVirt flavor if they want, but the goal going forward is to leverage the advanced technologies that Neutron has to offer. Okay? So let's talk a bit about the integration, how we did the integration. So first of all, we added the concept of external provider. So what's an external provider in oVirt? It's something that didn't exist before. It's an external product that can be used to provide resources. And the types of resources is hosts, it's networks, it's images for glance, and in the future we can add more and more resources because we want to be able to consume things that's externally. We want to reuse technologies that are provided from outside, and we don't want to abstract it just in an oVirt way. We want to be able to define it as an external provider. So this is just the basic concept. Currently we have a Foreman external provider which uses Foreman to provide hosts to the system, so you can actually get your hosts provisioned and handled by Foreman through oVirt. And we also, of course, added the OpenStack network provider. But what's even a network provider, right? So external network provider is just some external network manager that we use through oVirt, and it has some predefined API that we expect to use, right? So Neutron, of course, fits right in because it has this set API, this API version that we use, and we can just use it. We don't need like some proprietary implementation or drivers or stuff like that. We just talk, we'll see, but it's through REST API. We just send it command through REST API and it does its magic, right? And there's a slight distinction between the internal network, which is actually the network that we provision in oVirt, and that's the good old-fashioned statically defined network, and the external network. That is a network that is provisioned by an external provider, and they can be either discovered from the external provider. We can go and ask the external provider, like, doesn't have to be Neutron. Let's say maybe it will be UCSM. So we go to UCSM and ask him, like, hey, which networks do you have? I want to use some of them, right? Or we could export these networks outside, right? But as I said, these networks are a bit different because they're dynamically created. They don't exist on each host by default. And also the user doesn't have to manage it like he manages the oVirt networks. And what's nice, it's still the same permission model for both external and internal networks. So when you import an external network or create one from oVirt and send it to provider, we'll see how we do that, then you can actually use the same permissions and grant, like, these users can use this network and these users can use this network, and the users, they don't see it as an external network, they just know that they have network A or network B. For them it's all the same, right? So basically Neutron is just, as I said, it fits like a glove. It's just an external network provider, and it actually can be deployed with the user's choice of plugin. Like, we don't limit the user for specific plugin. He can choose whichever plugin he wants. There's a slight asterisk there, which we will cover later on, but let's say he can use whatever plugin he wants. And we offer two flavors. Either it's the Neutron-centric way, which says, like, I have an existing Neutron installation, I'm a Neutron admin, and I already created the service, and I installed the agents, and I created a lot of networks, and I just want to use them in oVirt and consume them in oVirt. So there's this flavor. And there's another flavor which is oVirt-centric. It says, I don't care really, I'm using oVirt. I don't really care about Neutron, but I know it's there and it can give me some advanced capabilities, so I'll provision the networks from oVirt to Neutron, and then maybe I'll use these advanced capabilities, but I'm using it through oVirt. I'm not going to the Neutron service directly. I'm not defining it myself, right? So how do we use Neutron in oVirt? How do we get it to work? So it's quite simple, just 6 steps, right? So first of all, we need to install the Neutron service, as we saw the API plus plugin. We need to add it to the oVirt system as an external provider. We need to add some networks from this provider, add some external networks. So either we import them, or we can add new networks and export them to the provider. And then we just install the host. We'll see how to do that. We install the host with the provider's agent for the specific plugin, and use the networks in VM, in the Linux, and just run the VMs, right? So first step is to install Neutron. It's really not part of the process yet. We hope maybe in the future to get it also in the process, to have the user just click install Neutron and it works, right? But right now he has to do it a bit manually, but it is the only step that he has to do, like, manually. So he goes, installs the Neutron service, configures the plugin, installs keystones, and configures keystone to use this Neutron service, to know it, to, like, have users for it and tenants and everything. And then he's done. He installed the main service, the core service, and the plugin, and he's done, right? And later on, he just goes to the provider's element in the tree, clicks new provider, and he gets this screen, like, add provider. So what do we see in the screen? We see, like, there's name, description, it's very basic, and then we select a type. So type, this can be like a foreman provider, it can be OpenStack network provider, it can be OpenStack image provider, right, for glance. And once you select OpenStack network provider, you get specific fields for that provider. So we need to select the networking plugin. So you can select either one of the supported plugins, or we can use our own plugin, given that the host can run it. Okay, and we need to enter the URL of the provider, just the URL to do the REST calls, the REST API calls. And optionally, we can use authentication. Like it's better if you use authentication because it's more secure. But we can also allow you to not use authentication if you want to do like testing or something like that, development. So you just enter the authentication field, and you have this nice little button on the bottom that says test. So when you click test, it actually tests all the connection parameters, tests the URL, the authentication, and it sees if you can access the Neutron, right? So you don't just create a provider blindly, and maybe later on it doesn't work. You can test it before you save, okay? And also in the screen, we can see there's agent configuration. So what's agent configuration? It's actually a template to use when installing agents for the provider. So we will see on the how it is used, but here we can define like Cupid parameters. It's just for the internal bus that the agents use, right? So we said there's agents for Linux Bridge and Open vSwitch, right? Everyone remembers that. So these agents, they communicate via a messaging queue, and here we can define these parameters for the messaging queue, and we can define a template for interface mappings. But we'll see soon how it is used, when it is used. This is just a template, right? It's just a central location to save this info, to save you from typing it every time you add a new host. Yes, question.
If you install, like let's say you use the OpenStack plugin and you install the OpenSwitch agent on each of the open hosts, then if you go to the OpenStack GUI, then these same hosts will be available to be used from the OpenStack GUI.
Okay, there's no problem. I don't understand what's the question. Like,
the question is basically the other nodes will be visible in the OpenStack GUI. That's the question. Will the OpenStack administrator be able to use the same host that we are using in Open?
I guess you will. I haven't tested with the OpenStack GUI, but if it's just discovering that there's an agent installed somewhere, or you can add it manually, then yes, you can use it. It's the same agent, it's the same technology. We didn't alter it. We just have something additional in between that helps us work with it, like a virtual interface driver. But the host can still be used in OpenStack. You can use it in Nova as well. You don't have to use it in oVirt. Okay, so moving on, we added the Neutron provider. We clicked OK. Now we go and we have either one of the two flavors. Either we want to use an existing installation, so we can go to the Networks tab and we have an import button. We click the import button and we get this dialog where we select the provider and we can see which networks it has to offer. So these networks, just the external networks that we created before, like the administrator created maybe 1,000 networks and wants to import them all at once, right? So we can just click this checkbox or select individual networks and click the button to move the networks to the imported networks list, right? The networks that we're going to import. And on this list, we can change the network name. We can select which data center these networks will be imported to, and we can set the permission. We can have, like, there's a special permission that allows all the users to use this network. So it's kind of a public network. Every user in the user portal will be able to see this network and attach it to his VM, of course, in the context of the data center of the cluster, but you get the idea. So this is one flavor. You have an existing environment and you just want to import the networks. And another flavor is adding a new network. So we can, just as we added a network before, we go click on new network and you get this screen where you can fill in name, description, and then we just say create on the external provider. We don't just want to create an internal network, we want to create a network that is provisioned externally. So we define the network, but its actual connectivity is handled by the external provider. So this saves the administrator the need to go and attach the network to physical interfaces, statically define it, etc. Right? So it's really powerful. He can now use Neutron and actually get all these networks connected to the interface for him, or to some interface for him. And how this is defined, it's by the network label. So the label, we'll see in a second that it maps to an interface on each host. So it just sets the network label, and then it would automatically be mapped to the selected interface on each host, right? So it saves him a lot of hassle. If he has 1,000 VM networks, and half of them on interface 1 and half of them on the other interface, then he doesn't have to go to the 10 hosts he has and on each one set up networks and drag all the networks on each host, right? He just select Neutron and tells him, Neutron, go do it, right? So this is the oVirt-centric flavor.
Mike, quick question for you.
Yeah.
So is this mapping to the Neutron, provider network extension, where it's creating, a particular VLAN in this case on that physical network called Red?
Yeah, exactly. It's mapped to the provider network extension. The label that is used is Red, and the segmentation ID is what you set in the VLAN tagging. And if you don't select the VLAN tagging, then Neutron will do his own logic and assign one for you.
Okay, so there you're using a tenant network, and it'll be of whatever type Neutron is configured to create for tenant networks?
Yeah.
I guess you already tunnel once those are supported, that sort of thing? Okay.
Yeah, exactly. Okay, so now that we added network, we need to install it on the host. So as we saw earlier, we did a setup networks in oVirt. Now we just can go and say when we install a host, we want to add the network provider there, or actually the network, install an agent for this network provider. So we go to the network provider tab on the new host dialog, and we select which provider we want to use. So we can say, I want to use the Neutron provider, and then we can see the type and the plugin that is used, and we see these Cupid parameters that we filled in earlier. So this is copied from the template. The provider was a template, and this is filling it in. So the agent that gets installed on this host can communicate with the service that you installed beforehand, right? So, yeah.
How do I install the agent if I already have 100 hosts configured with a company host?
You can use reinstall. It will also be available in the reinstall dialog, right? So just as simply you go reinstall the host and just select the external provider. And also the key part is the bridge mapping. So we map the labels that we said that allow a network to be attached dynamically to either interface, and that's what Bob was talking about, the provider network extension, but I won't go too much into details about it. So we can override this mapping for each host. So let's say in a typical installation of a data center, we have like a blade center with 10 hosts. These all 10 hosts have the same NICs. So if I did my setup correctly, did my bootstrapping correctly, and configured UDEV rules correctly, let's say I know NIC 1, ETH1 is always on the network that I call red, connected to the red switch, so I can use just the template red ETH1. But if I now go to another host that like a pizza that I installed separately, and I know that its ETH5 is connected to red, then I can just edit it for that specific host, right? So it's not like you have to use the same bridge mappings, right? So this works. These agents, they work currently for OVS and Linux Bridge, the both plugin types that have an agent. We can install the agent for you. You don't have to do it manually. you can go to the network provider tab and just select this provider and have it install it, right? So this is really powerful. This is saving the administrator a lot of work of going over to the host and installing everything manually. Okay, now that we have everything set up, this is the groundwork for using the networks. We just go add an interface to a VM, or as we saw in the new VM dialog, we have the network selection, and we just get these external networks. And as you can see, we don't know the user or admin in this case doesn't know what's like the implementation details, but he doesn't really care. He just knows that it's a network he can use for this VM, right? And this will work for him. Okay, so once we added the networks to the Linux, to the VMs, we just go and run the VM. And once we run the VM, we get the same capabilities that we get for oVirt networks. We will get quality of service, which is coming soon. We get the guest agent data statistics reported. We can know the IP that the network interface got inside the guest, right? If we have the guest agent installed. So basically the same baseline functionality. Right. So we have a bit time left. So I suggest we do a deep dive, see how it works on the host side, actually. So why is it called under the hooks? This section, right? So basically, VDSM, as I said, is the oVirt compute agent, right? It's responsible for handling the VM lifecycle, and it also, what it does, it connects networking and storage resources. But VDSM also has a hooking mechanism, which allows you to hook in a script that will run before VDSM sends a command to delivery, right? So how it works, like I send the command start VM to VDSM, and VDSM runs some scripts before it actually sends an XML to how to start the VM to delivery, right? So we implemented with this mechanism. This mechanism allows you actually to do everything. You can extend the capabilities of VDSM to like have crazy things. But why we use it? First of all, because it's a tech preview. The feature in 3.3 is going to be released in tech preview state. So we didn't want to commit to any API yet. And the hooking mechanism, actually, it's not really an API. It's just a mechanism that allows you to extend single host capabilities. So you have to have this hook installed on each host in order to have this capability. But you don't have to commit to any API, right? So that's one reason. And another reason is these hooks can be extended. So if now, as I said, like there's an asterisk on the supported plugins, like we support every plugin, right? But actually we support our hook, supports Linux Bridge and OpenVSwitch out of the box. But every third party can write his own hook scripts, which are really easy to write to support any type of plugin that Quantum has to offer. He just has to know how to do it, right? So this is the equivalent of, if you know what is the VIF driver in Nova, this is currently the equivalent in oVirt, using the hook scripts in VDSM. Okay? So basically I just went over this slide. So let's see how it works for OpenVSwitch. So basically how even OpenVSwitch works, the agent, before we go over to how we use it. Let's see an overview how it works. So first of all, there's a requirement in OpenVSwitch that the administrator has to create one vSwitch bridge that's called the integration bridge, and this is the bridge that all the VMs connect to, okay? And he also has to create a bridge for each provider network that he uses, like for each label that he maps in the provider, in the host installation dialog. We saw like there's a red on ETH1, so here he has to create like a bridge in between that to know that the red label is this bridge, and this bridge is connected to ETH1. So these bridges are all connected. The integration bridge is connected to all the bridges that represent each provider network, each label. And these bridges are connected outside. They can be also connected like not to a single VNIC. You can do, if you go from the neutron-centric way, then you can create bonds in these switches. OpenVSwitch supports very sophisticated setup, right? So this is just a setup that the admin has to do on each host that he wants to run the agent on. And then the agent runs and monitors the integration bridge and sees that once there's a VNIC on the integration bridge, then it actually goes, gets the information of the flow. The flow is what is the network connectivity inside OpenVSwitch. So it defines the network connectivity for this specific VNIC and how it should go outside, through which like physical interface, let's say. And it says the VLAN tagging. It also sets a lot of data on that flow, right? And after it did this, it will just monitor the port status in Neutron. So in Neutron, the port is the representation of the VNIC itself. When we create a VNIC, when we start a VNIC in oVirt and like plug it into VM or start a VM with a VNIC, we have to create a port that it will connect to. Okay, so like it's not the representation of the VNIC. It's like the port in the switch that you connect to, right? The port in the bridge, let's say the virtual bridge that you have. So the agent actually monitors the state and sees if the state changes, then the flows are updated accordingly. So if the port goes down on the bridge, then it has to cut the flow, and etc. So let's see it happen graphically. So basically, Livir starts a VM, and the VM has a VNIC, and this is all internal in Livir, and externally there's a tab device, which is just a Linux device that connects the VNIC to the integration bridge on OVS. This bridge, it doesn't matter to us how it's connected, right? There's some connection here, but the agent takes care of it. The agent knows how to set the flows correctly because it has the right configuration. It knows the bridge mappings, which we set earlier when we installed it, right? And the port ID, this is important because you send the port ID over the tap. You say, well, this tap is connected to this virtual port, right? And this virtual port sits on some network, and the network has a definition. Okay, so this is the first step. We just create a VM, connect the tap, and the tap is like a virtual wire that's connected to some port in the bridge. Next, OpenVSwitch agent runs and detects that there is a new tab device and says, okay, well, what's this tab device? I don't know it. Something is connected to somewhere on my bridge. I need to handle it, right? So it goes to the plugin, and this is done over the Qubit bus, right? For OpenVSwitch agent and the Linux bridge agent, this communication is on the Qubit bus, and it's an internal API that the agent uses against the plugin. But it's, from what I saw or from what I experienced, it's not a set API that you can really build upon, because you can't have like Linux bridge agent running with an OpenVSwitch plugin or vice versa. You can't mix them. Because, well, first of all, it doesn't make sense, but also the APIs itself, they collide. Because Linux bridge expects something and OpenVSwitch expects something else, right? So it just gets the port ID from the metadata on the tab, queries by the port ID and receives the port details. And on the port details, it says, well, this port is on such and such network, right? It has the network ID. So it queries the plugin. It says, hey, give me the details of the network by the network ID. And it gets the details. And what the details say, well, this is VLAN, and the VLAN tag is so-and-so, and the label is so-and-so, right? And this is the info that it needs. Now the agent knows how to set the flows, so it just goes and sets the necessary flows, well, for the tap. So it goes to the integration bridge and sets some flow, and it goes to each label bridge, each provider bridge, and sets the flow there. So he knows, like, this tab should go over through VLAN 100, and go exit through bridge red. And bridge red is connected to, let's say, ETH 0 and 1 in bold mode, okay? But it doesn't interest him. He just wants to know that bridge red is where the traffic should go. Bridge red would take care of the rest, right? So this is how basically Open vSwitch works. It's a high level. I know it's not too detailed, but I don't want to really dig inside. And how we use it, okay? So from oVirt perspective, what it does is actually on the engine side, when a VNIC is hot plugged or a VM is started with a VNIC, then a port is created for this VNIC on the Neutron network, right? So the VNIC is connected to some network, and we see that it's an external network. It's managed by this provider, and we tell the provider, hey, we need somewhere to connect this VNIC to connect the cable that goes out from this VNIC, right? So it creates the port on Neutron. And what happens, we have a hook to catch this event, right? So when the VM actually is trying to start, when VDSM gets the command, it runs the hooks before it does anything. Or when the NIC is hot plugged, it runs the hook. So at this point, there's already a port in Neutron, right? The port was already created, and we need to somehow connect these steps correctly, right? But in OVF, it's simple. You just connect to the integration bridge, right? You say, okay, let's connect to the integration bridge. The agent will do the rest because we already defined the port, and the agent should know how to handle it. And we just add this element in the oVirt XML that says virtual port type Open vSwitch, right? So this tells it, like, hey, this is Open vSwitch bridge, not a regular Linux bridge. And as I said, we have to set the port ID. Otherwise, the agent itself won't know what is this tap device. I don't know. Someone connected some cable to my bridge, and I don't know it. So if it has this port ID, then it can find the port and get the details for the connectivity. Right? And then it just, as I said, it does whatever we explained before. It says the flows, it takes care of the physical connectivity of this VNIC, right? So this is how Open vSwitch works. Linux Bridge, really simple. It basically does almost the same. I'll go over it really quickly because we have very little time left. But also VNIC is somehow started by oVirt, and the tap device here it's called tap. It has the first 11 digits of the port ID, right? Then very similarly, Linux Bridge agent detects that there's this tap device, and it does the same ping pong with Neutron plugin, gets the connectivity details, and he connects it. So he connects it, it creates a bridge if necessary, and it creates the VLAN if necessary. But Linux Bridge, it's only Linux Bridge plugin, it's only bridges and VLANs, right? Just like oVirt. Okay? And how we use it from engine perspective, it's exactly the same. We create a port and we say we have to connect the cable somewhere. And we have here we have two hooks, because there's a oVirt limitation that we can't have a dangling tap. We can't create a VNIC and have a cable that's not connected anywhere. So what we do, we actually connect it to the dummy bridge and just set the correct name, tap and something, 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 so that the agent can find it when it's calling. And on post-start, there's a hooks. There are hooks for pre-start and post-start of the VNIC of the VM. So then we just disconnect the tap, right, from the dummy bridge, and we get the dangling tap. And the agent can do his magic. Because the agent knows many things that we don't. It knows, first of all, which network it needs to go on. It knows the network type. It knows if it's VLAN or flat network, the VLAN tag, and it knows which interface to go to. We don't have this information. We could get this information, but there's no API for it, right? So, but it's correct. The agent, he should take care of the connectivity, not us. We just tell him like, hey, we want you to connect this cable to somewhere, but we don't know where. We just know where it should be. Okay. So this is basically the under the hood and under the hook, because we use hooks, right? So future work, what we have planned ahead of us. So like a small minor issue that we have really bad scheduling now because the networks are dynamic and we actually don't know which host is going to have which network available, and also it's very hard to monitor it. And because it's a tech preview, we didn't want to set any API, so we can't define the API for monitoring yet, but we will do it in the future. We'll allow you to know that actually your VNIC is connected to the network, but the network is down, so there's some problem. You won't get connectivity. Or we could know not to run the VM or not to allow VNIC on this host because this host won't support your network, right? So this one point that we have to take care of. And also, as I said, we have to monitor the connectivity after the VNIC is started to see if it goes down. Like maybe it was connected, but the physical link went down. So currently we do it for internal networks. We can't do it yet for external networks because of the tech preview limitations. And also, we would like to integrate the tenant concepts into oVirt, because now we just have this provider, but we don't have multi-tenancy. We can't let users in the user portal create their own networks and use them, right? Because there's no tenancy. So it's a thought that we're having to integrate this concept into oVirt also, and it will integrate really nicely with Neutron and other OpenStack services and multi-tenant services. Also, we would like to be able to manipulate the external networks, but also this a bit of limitation because the external network implementation is defined by the plugin type. So Linux Bridge, it's very simple. It supports the basic, like really low-level networking of flat network or VLAN. But let's say OVS supports also GRE tunneling. So GRE tunneling is much more advanced, and we don't have it modeled yet. But we would like to have the user be able to set this, to manipulate this if he wants. Also, as I said, we want to leverage layer 3 services. So actually, we didn't do it yet. We didn't have the time, but we do want to do it. We want to leverage IP address management is very powerful. We want to leverage load balancing. We want to leverage a whole lot of things that already exist there and should be easily consumable because we use the Neutron technology. We don't abuse it, right? And of course, we want to support more plugin types out of the box. So currently, as I said, we support Linux Bridge, OVS. There's some work with other partners, and we want to support much more plugins and maybe, I don't know, standardize a VIF model or something like that, because currently hook scripts, it's nice, but hook scripts is really an easy way to get what you need, but it's not a standard way. It's not an API. It's not something you can count on. It's very not very reliant way to work. So we want to standardize this and to work properly, right? And open questions, I'll leave it aside. So let's conclude what we talked about. We've seen how can we configure good old-fashioned oVirt networking. We've seen what's Neutron and how it's integrated into the system. We went over the OVS hook, OVS integration, OVS agent, and also really quickly about over Linux Bridge. And we talked a bit about the future work plan. And if you want to learn more about these topics, well, there's the Neutron page where you can start. In oVirt, there's a really detailed page that explains what's a network provider. And I'm sorry I forgot to put the link, but there's a feature page in oVirt that you should look for. It's called, actually it's called quantum integration because of all the name change, but we didn't change it yet. And there's also all the regular oVirt mailing lists that you can go to. And we have like 2 minutes for questions. If anyone has a really small question that I can answer.
There is no such thing as small questions when regarding this feature. Hello?
Yes.
Yes.
So I have 2 questions. One of them regarding the edit network part and connecting the host agent, with whoever it is on the, whether it's OpenStack or Linux Bridge, there is the binding between the physical NICs and the logical network. Does the edit network take care of that, or do we assume it is pre-configured?
Like, what do you mean the edit network?
Well, edit networks currently for standard network, oVirt network, configures per host the physical binding to a logical network. So who's doing the connection to the Neutron networks, the physical connection?
Actually, it's not. It's not done like in currently in oVirt networks, but we saw it. It's the label you define on each Neutron network, or if you define it outside of oVirt, you define a label, and this label tells it like what's my network, but it's a logical entity that represents a physical network. And on each host, you can map this label to a physical interface, or in the case of OVS, you can map it to a bridge.
Okay. So my question is, how is it done, this connection? Is it done manually? Do we assume it has a pre-configured labeling per device, per network, or do we do it internally?
No, we actually support both methods. You can either configure it manually in the agent configuration files, or when you install the host, you can select to install an agent. And in this installation, you can set the label binding. You can say, label red, if you encounter it, then you should go to ETH1. Label blue, it should go to ETH2, and etc.
Okay, so it's done by the edit networks, because this is the way it's done.
No, currently it's not like.
Yes, but it's a property you provide, either when you add a provider, you can add the mapping between physical host NICs and labels, and we are going to apply it on each add host that you add to the system. You can choose the provider, and we copy the properties from the provider. Or you can override the properties when you add hosts. You specify it in oVirt, and we make sure that when we deploy the agent on the host, we configure the value for you.
So oVirt takes care of this automatically. This is
yes. As long as, yes.
Next question. Am I correct? oVirt takes care of that. The engine takes care of handling this connection.
Yes.
Yes.
Okay, good. Next question is with OpenStack. It wasn't clear to me whether the integration switch is actually stays on, or do we use a different switch? because we have, let's say, red network, you gave an example, and the VM is actually connected initially to the integration bridge. So does it stay this way or encrypt internally, or does it, do we actually connect it to a different bridge down the road, the agent?
Yeah, you mean about the internal implementation of the OVS agent? That's what you're asking
Yes.
about. Yes. So, do you want to take it over?
Sure. When the tab device is connected, it's connected to the integration bridge. The integration bridge is the only bridge that you connect all your VMs to all your tab devices that represent the cables themselves. And later on, this bridge is connected to one or more other bridges that represent the labels. So by the label, by the network label, the agent knows to set a flow, and the flow determines where the frames should go. So if a frame arrives from one port on the integration bridge, there's already a flow defined that tells it go and exit to the port that's connected to the red bridge, or go exit to the port that's connected to the blue bridge, for example. But still, the tab device, it stays on the same port in the integration bridge. It doesn't move around. There's a flow connected internally. It's just like a normal switch, but it's virtually done, so you can connect it and configure it virtually. And this is what the agent does. It actually just configures the switch.
It goes through two switches, so each frame actually goes through two switches, if I understand correctly.
Yeah, exactly.
On the way out.
If you're looking at performance,
it's a general, just wanted to understand.
okay.
Yeah, that's the design currently. Okay, so thanks everyone for listening.